Hello and welcome to our March DS code putting live stream. Today is one of my favorites. We get to sit and dissect all the data bits from on paper to a real life meaning situation so that you guys at home and me can make sense of what the data is telling us. So my name is Tiffany Hall. I'm an alumni of TripleTen Software Engineering Program. I'm a full stack engineer and a product owner at Scholastic Inc., the world's largest publisher of children's books and a powerhouse in the digital education space too. I'm very excited that I get to be the host of the code jams and code puddings that we have here at TripleTen. Thank you so much for joining us today. This code pudding, like all of our code jams and other competitions, is one of my favorite ways that we get all of our students together from across the US. So if you're not familiar with what a code pudding is, then let me take a moment to just let you. So at TripleTen, a code pudding is a friendly competition that occurs for our students during their normal coursework. These are super short, just a matter of days, where groups of students get together and then they put in a lot of work to meet the prompt that we've given. So the code pudding has consisted this time of two parts: working with the data and building up a model, and then the presentation. So two parts for the data parts, and then just our presentation tonight. Last week, our participants were divided into teams and challenged to collaboratively build a machine learning model to predict the NCAA tournament winners based on historical data and team stats. And I don't know about you, but I'm definitely going to be taking notes tonight so I can go ahead and saddle up my DraftKings after this. So our teams only had 5 days to make their project. So, buyer beware there. The teams are going to show off all of their projects tonight. And then next week, the judges will review them based on the model and the presentation. The results are going to be posted on our Discord channel and socials on March 19th. All of our students can vote for their favorite project in the Discord poll, so keep an eye out for that. And then if you're not a student of ours just yet, go ahead and vote in the live stream comment section below, all right? That way we can get our audience award winner a prize, which usually consists of some piece of cheese from my cat. So hope you like cheese. All right, well, now it's time to get to the fun part. We're going to talk to our teams and we're going to see what they have accomplished in the 5 days since I've seen them last. All right. So first things first, we are going to meet with team number 1, ML Hoops. And that team consists of Galdino Falcao, Rawa Yusuf, Joe Kriya, and Aya Govindaraj. ML Hoops, take it away.
Hey everyone, we're ML Hoops, and today we're excited to share our project, a machine learning model that predicts winners in the NCAA March Madness tournament. For those who might not be familiar, March Madness is one of the biggest college basketball events of the year. It's a 64-team single elimination tournament that has fans filling out brackets hoping to predict the perfect outcome. The excitement comes from its unpredictability. Every year, unexpected teams pull off upsets, making it nearly impossible to predict with certainty. The best strategies rely on deep analysis of stats, trends, and team matchups, which is where our machine learning approach comes in. We wanted to see if data-driven predictions could improve accuracy, enhance strategy, and engage fans in a whole new way. Let's dive in. Before we get into details, let's introduce ourselves. We're ML Hoops, a team passionate about sports and data science. Our goal is to apply machine learning to March Madness predictions and see if we can improve how we pick winners. I'm Joseph and I focused on data preparation. Rawa, who's also a current student, worked on EDA and documentation. Galdino, an alum, developed the model framework, while Aya, also an alum, handled feature engineering and additional EDA. Together, we combined our skills to build a predictive model for this year's tournament. So what problem are we trying to solve? Our goal is to build a model that predicts the winner of any given March Madness matchup But there are challenges. Teams don't always play each other directly during the season, so we rely on historical data and performance metrics to fill the gaps. Other unpredictable factors like injuries or sudden momentum shifts aren't always reflected in the numbers, making predictions even tougher. Despite these challenges, our goal is to develop a model that identifies key patterns and gives us the best possible predictions. Next, we'll take a look at the data we use to train our model and how we analyzed key trends to make our predictions. You're muted.
Thank you, Joe. So we had our data overview. We had two sources, ESPN PPI, Basketball Power Index, and historical match results, and Kegel NCAA teams dataset. This takes us for our data points, and it was, we had 26 team states like points per games, defensive efficiency, or winning percentages, and extras. Match results from the 2025 seasons. We had 64 teams and pairwise matchups out of 4,096 possibilities. Only 509 pairs had historical matchups. Our target variable winner passed on the matchup result. Next, please. For our EDA, if we look at here, we will find our net rating influence to determine winning teams. When you look at the diagram, we had the top 20 teams that they are selected based on matchup net rating. When you go from down to up, down is the weakness and up is the strongest. So when you look at Duke Blue Devils, they are the strongest, and it's getting stronger when you go from this color to get darker. But when you look at Missouri Tigers, you will find that they are minus there. And it means that they were doing really poorly about the net rating, so it was so slow. From here, we go to talk about our futures with Dino.
Thank you, Ra. So in this slide here, we're looking to a correlation heat map in which we essentially compare the 26 aggregate features that we use versus the target variable winner. Just as a reference, the reference that we use is an aggregate method in which we take the features for team 1 and subtract for team 2 in order to get better results. And from this heat map, it's clear that BPI and net rating variables stand out as good variables tied to winning. Just as a reference, BPI means Basketball Power Index, is an ESPN aggregate metric that takes into account offense, defense, and pace variables. And the net rating is basically the difference between points scored and points allowed per 100 possessions. Next slide, please. So here we kind of show a little bit of the workflow. So we evaluated 5 different models with the random forest and the gradient boosting as the best performing models. So the workflow started basically with the data set split into training, validation, and test sets. We also perform a little bit of feature scaling to apply consistency across the data set. Next, we evaluated the models. We primarily focus on accuracy and F1 score. And we focus on iterated over different hyperparameters to get the best combination of outputs from each model. The result, as I mentioned, showed that the random forest and gradient boosting models were the best performing models. They hit about 68% accuracy on validation test sets and perform better, way better than logistic regression and decision trees. We also further validated the results using cross-validation techniques and also compared to a dummy model. Lastly, the random forest trained way faster than gradient boosting. So our conclusion here is that it makes for us the top choice for predicting the winner for the NCAA tournament. And I will pass over to Usher.
Thank you, Dino. So as Dino explained, here is the visualization of each of these model. And like he said, the random forest and gradient boost, they both the winners for this prediction, and the random forest was pretty quick. So we would recommend going for random forest. Looking at the feature importances, the net rating and BPI as we saw in the EDA before, they are the actual top predictors for this model to perform well. So coming to the limitations. Before we jump into limitations, so now we have this model. We did an additional bonus step in that, which is so since the model, if you give team 1 and team 2, it can give the result of which team will win. So with that model, what we did is we decided to do the brackets. So brackets is nothing but out of the 64 teams, the round 1 will be 31 teams, and the round 2 will be 16, and then 8, and then 4, 3, so it's 4, 2, and then 1. So we did a random shuffling, and based on like first team 1, team 2 mapped it up, and the model decided a winner. So based on, and after for the round 2, these two are selected and selected for the round 2, like that. Like we reduce the team, and finally with our random variations, we came to know that the Auburn Tigers is our model predicted winner. Let's see the match, how it goes. So coming back to the limitations are with since we don't have all the head-to-head matchup in the seasons, so those teams matchups data we missed it. And secondly, there was some kind of bias because for certain teams they played more than one match with the tied wins, so we ended up taking the most recent win, giving the winning target variable to the most recent win. So there is kind of a bias there, and the model is still dependent on the historical data, so we missed to include the real-time data. So these limitations that are our future recommendations, where we can take the real-time data, historical season, not just this year, for the past years, and more player level stats would help to take the model to the next level. And as a key takeaway, the random forest model is the one we would based on evaluation we would recommend, and the feature importances are the net rating and PPI for the model to predict well. That's all, and I'm open the forum for questions. Thank you.
All right, that was wonderful. Thank you so much. Okay, I'm taking notes. Did everyone take notes on that? We've got one team's recommendations. If the second team comes back with different recommendations, then I guess I'm gonna have to flip a coin. So hopefully we'll see what happens. Really great presentation. Thank you guys so much for starting off the night. Let's just kind of open it up to your team and see, how was the experience? There's a lot of alums on this team. I know Galdino's been on this side of the coin a couple of times now. So how was it this time around?
I mean, I think it was great. Usha has a lot of experience as well, so also we learned a lot from her. And I think that everyone kind of contributed the best way possible. So I think it was a good interaction over those couple of days. You have the time constraint, right, which is always difficult. You have a weekend in the middle, but I think we kind of tried to manage that well. Everyone participated, contributed to the project, and I think in the end, it's the result that we represented, right? So overall, I think it was a very positive experience.
Fantastic. Since we have so many alums on this one, can one of you guys take a minute to explain that EDA part again? Because that is something like really cool display that you guys had, but I'm not sure, not being a data science person, I understand what an EDA is and where it fits in with machine learning.
I can take that question.
Great.
So EDA is an exploratory data analysis.
Okay.
And even before we start doing the analysis, like we're building the model, in real time, like since I'm working day to day in data science, we've got 1,000 features, and to decide, even to select what features we need this EDA. So EDA is nothing but it will provide a visualization stuff. If you have thousands, millions of data, you can't just look at, okay, it's like a spreadsheet. You can just look at the spreadsheet and see, what data is, what features are most important. So for
Sure.
that, to have an aggregated view, we have this as a graphical representation, and that will easily tell, like pictures tell 1,000 words, right? So that will give an idea, okay, what the data is, how it is laid out, what is the which feature is important, which feature is not so important.
Mm.
So in my presentation, which Rava gone over, is the net rating. So I can, like, if you don't mind, I can quickly pull that and show you.
Yeah, please do.
Thank you. So I'll go back because it's an interesting project. So I would like to share that. Are you able to see my screen?
Yes, ma'am.
Okay, perfect. Okay, so going here. So this is like we did an EDA on the net rating. Net rating
Yeah,
means,
cool graph.
yes, exactly. So based on this EDA, it clearly says the Duke Blue Devils. This team matched up with Auburn Tigers. Okay, again, I think it's the Clemson Tigers, and it matched with Maryland team. Okay, so of all
Okay.
the three teams, this team is a clear winner. So like they scored very well. So this is, you can't see in just this information, you can't see just looking at the data set, looking at the Excel spreadsheet. If you do the aggregation and put it in a presentable way, it clearly shows, right? The people who, the net rating is the main predictor who will win. So whoever has the highest numbers, it clearly shows those are strong teams. Whoever has the lowest numbers, those are in blue color. So those
Mm.
are like, weakly performing team, especially the teams with negative values. They are poor performance. It will be a miracle if they win the game.
All
So
right. So if you're looking for a Cinderella pick, the ones in blue are the ones to go with.
yes.
Got it. Fantastic. And then just one kind of last question in terms of like, it was a tight timeline. How was working together in terms of like, what structures did you guys set up so that you could collaborate together? It's only 5 days, so it's a lot of, kind of jamming in there. But did you guys have any Discord or texting or Snapchatting that you guys found to be successful there?
Yeah, we actually we had one group on Discord, and one of the
Oh.
things that I want really to mention about that, this is my first time because this is my first project to do with TripleTen. So one of the great things that I learned how to deal in a teamwork. I saw everyone is trying to like fix what he can and work about the part that he is really great or he has a strength point in that, and the other each one of us, we see what is left there and we go to start to work on the others. As a team, we had multiple meetings per the day, and mostly we were there to attend. And if someone of us, he had something that it doesn't allow him to join, they will continue working and they putting for us like notes what happened and what is the update. So they keep us always updates, and they kept us as one unit. So I like that a lot.
Oh, that sounds wonderful. Like the Weather Channel, constant updates. It's fantastic. I'm so glad to hear that you had a good first time experience. Then that means I'm probably going to see you next month too. Plug.
Yeah, for sure.
All right. Thank you guys so very much for being our first team out the gate. I appreciate your answering all my nerdy little questions. That team is ML Hoops, and that team consists of Galdino Falcao, Rawa Yusuf, Joe Kriya, and then Aya Govindaraj. Okay, so our next and last team for the evening is Beauty Behind the Madness, which obviously, talking about me. So Beauty Behind the Madness, that team consists of Mohammed Boutam, Matthew Baglietto, and Alfonso Houston, and Jael Faldu. Take it away, Beauty Behind the Madness.
Should I start?
Go for it.
Okay, so March Madness is unpredictable, but with data and machine learning, we can make smarter predictions. Today, I'll show you how we build a model to forecast game outcomes. Before starting, let me introduce my team. Our project name is March Madness Machine Learning Predictor. Team name is Beauty Behind the Madness, and team members are Jill, Alfonso, Matt, and Mohammed. Next, please. So I'll start with a brief overview. So the project goal is to build a machine learning model to predict the winner of NCAA March Madness matchups. For this, we used historical game data and test statistics of top 64 team to create a dataset for training and testing. As you guys can see on the right side, I have kind of a flow chart. First was data source. We had two data sources. The first was Kaggle dataset with NCAA team stats for 2025. And another one was ESPN basketball website, which we used to get BPI to identify the top 64 teams for the 2025 tournament. Following this, we did EDA to find out that which features are the best. And following this, we also did a visual representation of dataset. Doing all of those, we finally created 358 team matchup rows starting from November 2024 till February 2025 for training the program, which includes top 64 teams. And use those to develop a model which resulted and help us predict marked winners when teams play each other in 2025. Next.
We had a lot of features in the data sets that were given in regards to the team's performance and also the players' performance. It took high attention to details of each statistics to distinguish the ones with the most importance. Some columns that were used are, for example, the team BPI, the offensive efficiency, the defensive efficiency, the tempo, experience, and the rating. Next slide, please. Our objective for the exploratory data analysis was to see how metrics correlate with the game outcomes and guiding our model building process. The data visualization is crucial to conclude which feature is most important than the other feature to use them in training the model. There was key differences between the teams, and the statistics were close to each other since all of the teams are from the top 64 teams in the tournament. Before we ran the EDA, we cleaned the data and made sure there was no missing values, and we also renamed the team one winner to the winner column to not to have any error when training the model. Next slide, please.
So next, we're going to get into some visuals. We have our graph one, which is our feature distributions. And we pulled the stats for the top 64 teams and created matchup-based rows and plotted these distributions to ensure the data looked sound. Overall, we found that the metrics appear within accepted ranges, giving us confidence to proceed. Again, some of the important features are BPI, offensive and defensive efficiency, tempo, and etc. Excuse me. Next. Here's our second graph. It's a comparison of key stats from the winning versus the losing team. And here we found that the winning teams generally show a higher BPI and efficiency metrics, suggesting these features may be strong predictors. Stats like BPI, offensive and defensive efficiency are slightly higher for the winning teams on average, where stats like experience and rating have a small consistent edge for the winning teams. Next, please. And graph 3 is our feature correlation heat map. And in summary, we found that higher BPI efficiency and rating consistently is associated with better win probabilities. And where we see the positive correlation of offensive and defensive differences with team one winner, and a negative correlation of strong team two stats with team one winner. So this shows us that if team two is strong, team one is less likely to win. Off to you, Fonz.
All right, so yeah, so basically the main point of this project was to determine which teams won and which teams lost. And when it comes to machine learning predictions, one way to ensure the accuracy of your models is to make sure that these classes with the binary outcomes are equally represented. As you can see on the chart, the bar chart on the left side, you can see that the loss, which is the blue column, is significantly higher or slightly higher than the red column, which is the wins. After we did some upsampling, which is essentially bringing this red column, the wins, up to the same level as the blue column, which is losses, we end up with the graph on the right. And this right here, doing this ensures the accuracy, ensures the accuracy of your predictions in the machine learning training. So for this project, we utilized the cat boost classification model, and we essentially, the reason why we went with this is simply because it's a gradient boosting model, meaning that it uses simpler models and build upon. It uses simpler models in conjunction with each other to basically to increase the level of accuracy, if that makes sense. And another couple of things we did for just help with the overfitting and the target leakage. And then another reason is just because the way we manage our time, we couldn't really hit other models. But when it comes to classification models, one way to assess the performance of those models is the accuracy score, and it's pretty straightforward. Accuracy score of 1 indicates that your model has perfect accuracy, whereas 0 is on the bad end. And as you can see, before upsampling and after upsampling, our scores are relatively high. But with the validation accuracy for both accuracies for both before upsampling and after upsampling are slightly lower than the test set. That's because of the hyperparameter optimization method we use. And just to break it down to you guys, hyperparameters are just settings that control the behavior of your model's performance. We use a grid search method, and that's basically like, just imagine you pulling out a set of objects out of a hat and combining them together and seeing what kind of output you get. Well, the goal of this is to basically bring together a combination of factors or settings to see which combination produces the highest output. And that's how we ended up with our test set accuracy. That's on the bottom, and essentially it. Next.
To conclude, predicting the winner of the tournament mainly depends on the team's history. So we look at all of the data, like for example, from the past year, but because it would be like very big, we decided to choose of this season that started in November. We try to use this data like to be trained to have valuable results. The models like random forest, logistic regression showed accuracy of less than 70% when we tried to train them, which is not enough to depend on it to predict good results. So overall, the cat boosting was the effective and in analyzing the team matchup statistics that we had in our data set. Next slide, please. Thank you. Thank you, everyone.
Yay! Well done. Well done. Okay, so the first question I have is who wants to answer the question for all of everybody watching? What is the difference between AI like ChatGPT and Claude and the machine learning stuff you guys are working on? Because that is always a question that is coming up. I mean, you're gonna have to, I know Alfonso's face is like all of it, like, how long do we have? But just like summarize it for like my favorite Aunt Vicky who is, at home in Florida kicking in, doesn't understand the difference.
I can take this question.
Get it,
So,
Mohammed, get
uh,
it.
machine learning is based on the data that we already have. So, we try to make a prediction, and to make this prediction is by doing the machine learning and training the models, like, for example, random forest, decision tree, cat boosting, and the others. As for the AI, I had like a short experience of working with companies that um, does like a generative AI. So
Okay.
what they do is like they put the input, like people, they answer the questions that any person might uh, ask. So we predict and we answer
Oh, okay. Okay. So
for
make
this
sure I
question.
understand. So with the machine learning work you guys are all doing and showing us, you guys are using all of the models and the code and all of those things to put data in, just straight data, and then you make predictions from that. But the
Yes,
AI stuff is like it is scouring answers and is just trying to match an answer to a question. So it's
yeah,
less about the predictive piece of it and analyzing.
yeah. It's like a pool of answers.
Pool of answers versus a pool of analysis.
Yes.
Fantastic. That was great. Good job, Mohammed. That's a tough one every time.
Thank
Well done. Okay, so how did it go? I know Alfonso, you have been here before. Jill, you've been here before. How
Yes.
how did it go
I can,
second time around?
I guess Jill can speak on that, I guess.
You're like, I'm gonna fade and just go away.
It was kind of a good experience because like if I had the same team members from the previous core jam, then I know how they work. But like
Yeah.
making and prepping for like a job opportunities or working with a team every time a different team helps more you to prep and how would you work better when the environment is changing around you every time. So
Mm.
that's how it like I guess that's like preparing me more about like for future. And like when I saw Alfonso in my team, I was like, he has some feedbacks about his core gem. I have some feedbacks about my core gem experience.
Yeah.
So we can both add that together and we can try to get it better this time. Because
So
like
iterating on your own processes.
yes, like last time I remember my team went over time and others team went over time too. And
Yeah.
then also I also read the feedbacks how we missed writing some of the comments in every course. So this time I
Okay.
was telling them to make sure that we write comments. So if somebody who wasn't part of our team can at least understand what each code means, like why we are doing what we are doing. So
Oh,
kind of like
fantastic.
being participating before helps me to understand what am I missing and I can improve it more better.
Oh, that's fantastic. I love hearing that. Makes my little teacher heart happy. That's
Yeah,
fantastic. Well, so then how was it for you, Matthew? We haven't heard from you. How was
Yeah,
it?
so this was my first one, and when we started, it was nice to have two experienced people on a team. They were able to explain, what I'm going to, be seeing throughout the jam, and yeah, we were able to kind of play off of each other's weaks and strengths and weaknesses.
Yeah.
Um, right from the start, as soon as the teams were announced, Mohammed started up a Discord server, and I don't think we stopped communicating from when he started that server to, you know, 10 minutes before we got on the call.
That's
So not
fantastic.
only, yeah, did we work really well, we got built like a nice little relationship between the four of us, and it was a great experience.
Oh, that's wonderful to hear. Yeah, I do see, as someone who does a lot of these, there's a direct correlation in the outcome of the projects and presentations, directly to the amount of communication that the team has been able to forge for themselves in whatever platform, in whatever way, however it works, right?
Yeah,
So I'm glad to hear
and the
that.
challenge we had was, Mohammed, myself, and Alfonso are on Eastern time, and Gilles on Pacific. So, working our schedules around each other.
I feel you, girl.
Yeah, it was a challenge, but yeah, we got through it, and we
Yeah,
didn't miss a
I
beat.
also, that's a great point though that I like to bring up for all of the people watching is that you guys are working across all kinds of time zones. And it's a great opportunity for when you're working, in the future post boot camp. I'm in a mountain time zone. I work East Coast hours, but I have devs that I work with that are in Africa, they are India, they are in New Zealand, like all over the world, right? It's a global industry. And so being able to navigate time zones and figure that out is a hard part, but a real part. And making sure you have lots of coffee for those early morning calls if you're further west. Okay, so let me ask you one final question for your team. What was your favorite part? Anyone can answer in the team. What was your favorite part about the actual project? So not necessarily the like, oh, I love working with people. Like, cool, we know that's great. That's a good thing. But like the nerdy little data part that like nobody is going to get except the other data students that are going to watch this.
I mean, I can speak to that for my team. Yeah. Um, I definitely. Well, in general, I'm gonna say this little cliche thing, but the whole project, the whole time was it was we really enjoyed it. But I think we started. I think that I think the time the very beginning of the project, like gathering the data sources and like determining what features we should use from the Kaggle website, the data set,
Mm.
and like kind of building out that initial training data set was what we kind of like went like crazy in. And it's just that right there was kind of like, I guess, a nerdy, lovey feeling. I guess we all share.
Yeah, you guys did have a lot of questions in the brief about the data piece because I know there was thousands upon thousands. It was an
Yeah.
exponential data set you guys had to start with. Well, it's really amazing that you guys were able to come up with anything from that, let alone come up with things that I can definitely use to pad my retirement account. So I appreciate all of your efforts in advance. All right, that's going to wrap it up here for us. That team was Beauty Behind the Madness. And that team consists of Mohammed Boutam, Matthew Baglietto, Alfonso Houston, and Gilles Feldu. I'm going to get these names. All right. So that wraps us up for tonight. For all of us here at TripleTen, thank you so much for watching our March code pudding presentations. Thank you so much for voting for your audience favorites. Don't forget. So if you're a student, you'll vote in the Discord. If you're not a student of ours yet, you vote in the YouTube channel below. And then the votes will be tallied and our judges will be judging next week. All of our results will be on March 19th in Discord and in all the other socials that you may follow us in. I want to send a special thanks to everyone who worked behind the scenes to make sure these things work and work well. Daniel, who's been our data mentor for this Code Jam, Camilo, Alyssa, Alina, Olivia, Dennis, Anastasia, and of course, my cat Sharkbait, obviously, paid actor. Thank you again for all of you participating. I really appreciate you guys having the courage to come on. Again, I am always so impressed to see the enthusiasm come through in your projects, especially given that they are such short time frames. But I love seeing when it all comes together. So thank you for sharing those. My name is Tiffany Hall, and you can find me at Instagram as Tiffany Codes, and you could probably find my cat Sharkbait organizing a union for better treat conditions. Thank you guys and have a great evening. Bye.
Thank you. Bye.
Thank you.
Good evening. Bye.